Okay, ladies and gentlemen, today we're going to be learning about another set of special right triangles, the 30, 60, 90. So for this one, we're going to start off with an equilateral triangle. So in an equilateral triangle, you know that all the sides are congruent and each angle then is 60 degrees. And in order to create our 90-degree angle or 90-degree triangle, we're going to drop an altitude from that angle. Alrighty, so when we drop an altitude down from one of the angles, we actually split this side into two equal parts. So if this side is A, so A is half of the whole length, and these two lengths are equal, the hypotenuse is going to be 2 times that side. And then we're going to come up with a rule, or we're going to use Pythagorean theorem to help us figure out what the other leg is. So, but initially, we drop our altitude. It ends up creating a bisector since we have an equilateral triangle. And since it cuts this side in half, we're going to say, hey, this is like A. The other side then has to be twice as long since those two sides are equal. So now if I say that so here we're going to do the shorter leg. So I'll do the short leg. And then we have the longer leg, and then we have the hypotenuse. So now we know that we have the shorter leg because we have the 60-degree angle here. If this one's 90 degrees, this angle up here has to be 30 degrees. That's in just this triangle. And we're not worried about the other one. So, and if you think back to our triangles unit, we learned that the leg opposite, or the side opposite the smallest angle, is going to be the smallest side. So this A is always going to be our shorter leg, and it's always going to be opposite that 30-degree angle. So if I have a shorter leg of 1, we know that my hypotenuse has to be 2 because we're just doubling it. Likewise, if I have a shorter leg of 2, my hypotenuse is 4. If I have a shorter leg of 3, the hypotenuse is 6. If I have a shorter leg of 4, the hypotenuse is 8, because I just doubled those to get the hypotenuse. Now what we can do is we can use our Pythagorean theorem to help us figure out what the rule is for the longer leg. So leg squared plus leg squared is equal to our hypotenuse squared. So 1 squared is 1, 2 squared is 4. In order to get the leg by itself, 2 squared minus 1 squared, or 4 minus 1 is 3. So my leg is going to be my square root of 3. And remember, we can have like an invisible 1 there. Next up, 2 squared plus my leg squared is equal to 4 squared. So 4 plus my leg squared is equal to 16. 16 minus 4 is 12. When I take the square root of both of those, we are going to simplify the square root of 12. 6 and 2, 3 and 2. I have 2 sets of 2, so I'm going to have 2 square roots of 3. Do we see another pattern here yet? Let's do one more. Alrighty, let me erase some of this. Okay. So here we have 3 squared plus our leg squared has got to be equal to 6 squared. So 9 plus my leg squared is equal to 36. 36 minus 9 is 27. So when I take the square root of that, so 27 is just 9 times 3, and then 3 times 3. So I'm going to circle my set of 3's. So we've got 3 square roots of 3. Alrighty, so I'm going to pause this video here to see if you can figure out what goes in the blank there for when you have your short leg as being 4. Hopefully, you figured out that should be a 4 square root of 3. So when we have our 30, 60, 90, your shorter leg is going to, like given your shorter leg, your hypotenuse is always double it. And then your longer leg is going to be your shorter leg times the square root of 3 every single time. Now, again, once you get 2 out of the 3, if you kind of forget some of these rules, it's really not the end of the world because you can always use Pythagorean theorem and just simplify so that you have it in square root form or simplest radical form. Alrighty, so here we go. We've got our rule here. Oops. So we have a 30, 60, 90. Don't judge the drawings here. Okay. Let me switch those up because not that I ever draw anything to scale, but let's pretend to make it a little bit more drawn to scale. I'm just going to flip-flop those so the shorter side does really look shorter and the longer side really does look longer. Alrighty, so we have our shorter leg. So we have the short leg. Our hypotenuse is 2 times your short leg. And then your longer leg is going to be your short times the square root of 3. You don't really need to have the dot there. Or if your shorter leg is A, your hypotenuse is 2 times A, and then your longer leg is A square roots of 3. Whichever way you need to kind of think of it is fine. Alrighty, so let's kind of see this in action. Opposite the 30 degrees is 12. So if I double it, I get 24 for my hypotenuse. And my longer leg has to be 12 square roots of 3. Again, given my shorter leg, so my hypotenuse has to be 10. And then my longer leg is 5 square roots of 3. Alrighty, and I'm going to do a couple more examples. I didn't find ones that I liked, so I'm just going to throw some up here. Okay, so if I'm given a hypotenuse length of 20, the shorter leg has got to be half of it, so that's going to give me a shorter leg of 10, and then my longer leg is 10 square roots of 3. So here we can do another one. If my hypotenuse is 36, half of that has got to be 18, and then we have 18 square roots of 3. And then here's where we're going to kind of go with a trickier example. If I'm given a length here of like 8 square roots of 3, in order to get my shorter leg, we want to do your 8 square roots of 3 divided by square root of 3, which would give us an 8, and then you can double it to get your hypotenuse. And we'll do this one more. So, or if I have like, say, 7 square roots of 3, if I take 7 square roots of 3 divided by my square root of 3, those will cancel out, so I'll be left with 7 for my shorter leg and double it to get my hypotenuse. So tomorrow's practice will be just practicing these 30